Continuing in chapter 9, and the first topic we're going to hit on is called the Pythagorean theorem. The Pythagorean theorem is a very important theorem to find missing sides of a right triangle. So the first thing we're going to do is we're going to jump right into the parts of a right triangle. So we have three parts that we need to make sure we know. The first part is called the hypotenuse. Okay, the hypotenuse is directly across from the right angle, and it will always be the longest side. Okay, it will always be the longest side of a right triangle. The other two sides that we have are what we call legs. So we have one leg here, we have another leg over here. So we have two legs, and those two legs, if you notice, come together to form the right angle there. Okay, so we have the hypotenuse, which is opposite. The legs come together to form the right angle. So what we need then is we have this formula, this theorem. The theorem simply says that if I take the two legs in a right triangle, we're going to call them leg A and leg B, and I square them and add them together, that they will equal the hypotenuse squared. Now, that is how we know if something is a right triangle. It has to abide by the Pythagorean theorem. So again, if you think of it, you've got a leg squared plus a leg squared, and that will equal the hypotenuse squared. Okay? So when you look at a figure, when you look at a Pythagorean theorem, you have these special rules, and that is how we know if something is a right triangle. Well, if we can use it to determine if it's a right triangle, then we can also, given two sides of a right triangle, be able to find the third side. So let's use Pythagorean theorem here to find the third side of a missing triangle. Now, we're going to ask you to do one of two things on your answer. When you find your answer, when you find x, we're going to have you write it as a whole number or as a simplified radical. Okay, just like with fractions, if you have a radical, you need to make sure it's simplified. All right, so we look at this and we kind of start off by saying, okay, what am I given and what do I need to find? Well, here is my x. Notice it is directly opposite of the right angle. So this is the hypotenuse, which makes this a leg and this a leg. So to put this into our formula then, Pythagorean theorem, we would go 4 squared plus 6 squared, and that equals x squared. So then 4 squared, that's 16. 6 squared is 36, and that gives us x squared. Add those together, so 16 plus 36 is 52. Then how do we undo a square? Well, we undo it by taking the square root of it. So now we know x is equal to. So now what we do is we look at 52. 52 is not a perfect square. So the next thing I say is, can I simplify it at all? And the answer would be yes. 4 times 13 goes into that. So I'm going to bring the square root of 4 out, which is 2. So my final answer here would be 2 square root of 13. And that would be our final answer. We're not going to a decimal yet. We're just keeping it as a simplified radical. Okay? Let's go over to the second part. So the first thing I always do is I find my right angle. I go directly across. This would be my hypotenuse, which makes this a leg and this a leg. So now when I set this one up, I'm going to go leg squared, x squared, plus 7 squared is equal to 14 squared. So now I square those, so I have x squared plus 7 squared is 49. 14 squared is 196. So now I'm going to subtract the 49 from both sides. And that's going to get me x squared is equal to 147. Then I'm going to take the square root of both of those. And I get x is equal to the square root of 147. Then what I need to do is I need to look at 147 and try to figure out, are there any perfect squares that go into 147? Okay, so we start looking through. We go through here and we start kind of going. And I look and I say, okay, about half of that, about 147 is about 73 and a half. So I start there and I go 64. 64 doesn't go into it evenly. Oh, but 49 does. So what I could do is break this into 49 times 3. Take the square root of 49, that's going to come out. And that would leave me with 7 square root of 3. And that's how we would find that. So we simplify those radicals at the end. Okay, so I come back again. Here's a third example. I'm going to start off. I'm going to start here. This is my hypotenuse. It's opposite of my right angle. Here's a leg. Here's a leg. So now I take my 2 legs. I'm going to square them. So x squared plus 3 squared equals 5 squared. I'm going to square that out. So that would get me 9 and 25. I minus my 9 from both sides. So that's going to get me x squared is equal to 16. Take the square root of both of those. Square root of 16 is 4. So my third side, or my leg, x would be 4. Okay? Now, that leads us, this last thing here, the last one we just found, is what we call a Pythagorean triple. Now, I bring that up just because Pythagorean triples are something that show up, and if you memorize a few of them, you will start to spot them. They are also very common to be on standardized type testing situations, so it helps you just solve the problem a little quicker. Okay, so what is a Pythagorean triple? A Pythagorean triple is a right triangle where the legs and the hypotenuse are all whole numbers. So, for example, a 3, 4, 5. Okay, now they can disguise these also by, for example, multiplying all of them by 2. So that would be a 6, 8, 10. They could multiply them all by 3 and make it a 9, 12, 15. All by 4 and make it a 12, 16, 20. And they could keep doing that. Another very common one is a 5, 12, 13. So when you look at that, they could multiply that by 2 and make it a 10, 24, 26, and so on and so forth. And there are others, but those are probably the 2 most common Pythagorean triples, and I just wanted you to know what those are called and to be on the lookout for them. Just makes life a little easier if you spot those. Now, the other thing that we need to talk about, though, is this thing called the Pythagorean inequalities. Now, Pythagorean inequalities, here is what we know. In a triangle ABC, where C is the longest side, in other words, it is the hypotenuse. Okay? So C is the longest side. In a right triangle, it would be the hypotenuse. Okay? So if I have a right triangle, it is the hypotenuse. These statements are going to be true. So if a squared plus b squared equals c squared, then we know this triangle is a right triangle. Okay? We know that because if it follows the Pythagorean theorem, then it has to be a right triangle. Okay, let's go to the next one. If a squared plus b squared is greater than c squared. So the 2 sides squared added together is equal to the third side, which was the longest side. Then we know that this triangle is actually going to be an acute triangle, which means all 3 angles are acute. Okay? So if it's a squared plus b squared is greater than c squared, then we know it's an acute triangle. The last one we have is if it is less than c squared. So if a squared plus b squared is less than the longest side squared, then ABC is an obtuse angle, which means, and because we know this from earlier, the longest side is always opposite of the largest angle. So we know this angle has to be bigger than 90 degrees. Okay? So it has to be bigger than that. We know this angle is exactly 90 degrees. And since this one is the longest here as well, we know this angle has to be less than 90 degrees. Okay? Because it all has to be an acute. Okay? So you know that piece all the way around then. So let's classify each of these triangles as acute, right, or obtuse. So I take a look and I say, okay, who is the biggest angle here? Well, we got to find that. We got to find the largest one. So if I look, I have 1536. I'm going to find what is the measurement of 4 square root of 95. So I'm going to go 4 times the square root of 95, and that's going to get us 38.98. Okay, 38.98. If you round, 38.99. Now, that's enough to know that this has to be the largest because 38 is bigger than 36. So now what I do is I do a little bit of math. I'm going to go 15 squared plus 36 squared. What are you in comparison to 4 square root of 95 squared? Okay, so let's do a little bit of math. So we're going to start off and we're going to go 15 squared. Well, that's 225 plus 36 squared. And 36 squared is 1296. I'm going to add those together. And that's going to give me a total of 1521. Then I come over to the other side. If you use parentheses, you could do this all in one step. Parenthesis 4, square root of 95, parenthesis squared. And we end up getting parenthesis 4, square root of 95, close it, squared, and that ends up giving us 1520. So 1521 is greater than 1520. So since the two legs is bigger than the other, we know this is going to be an acute triangle. Okay? Let's try the other one now. So the first thing I need to do is figure out what is 3 times the square root of 34, and that comes out to be 17.49. So again, that is the largest angle, or the largest side. Sorry about that. That's the largest side. So now what we're going to do is take that and set it up. So I've got 9 squared plus 14 squared. What are you to 3 square root of 34 squared? Okay, so now we go through 8 squared, or 9 squared is 81. 14 squared is 196. If I take 81 plus 196, that's going to give me 277. Then on the other side, I'm going to go 3 square root of 34 squared, and that is going to give me 306. So this time, 277 is less than 306. So my largest side, my longest side is squared is bigger than that. So that means this must be an obtuse triangle. Okay? And that's how we use that inequality theorem, and that's how we do Pythagorean theorem. Again, if you have further questions, please come see me. I would love to help you and love to explain it further if you need that.